Our final shattering story starts with a cracking demonstration. Watch as the wine glass explodes under the blowtorch. Yet the coffee pot survives the searing flames. But why is this? The secret to this amazingly tough glass all starts out here at a factory in France. Ordinary glass shatters when its temperature is changed too quickly. But borosilicate, or heat-resistant glass, can withstand the thermal shockwave of rapid heating or cooling, and it all starts with a pile of sand. Borosilicate is excellent for making laboratory beakers and oven-proof kitchenware that can go from the freezer to the oven to the table. This sand is the same as you would find on a beach, but with all the litter and seashells removed. As well as sand, scientists will add a mixture of chemicals including sodium oxide, boric oxide and recycled glass. The raw material is fed into this furnace, which burns at around 1550 degrees Celsius. The flames burn so brightly they can't be seen without a filter. Inside the furnace there are 6 burners and 3 separate chambers. The sand and chemical mixture is continually fed into the first chamber, where it's melted by the intense heat. As more fresh material is poured in, the molten mixture is forced to flow into the second chamber through narrow vents. In the second chamber, chlorine gas is pumped through the molten liquid. It absorbs impurities and carries them to the surface. This makes the surface layer unusable for now, but it isn't wasted. This layer is diverted out of the furnace and plunged into water to cool it down. This waste glass is the recycled glass that's taken back and added to the sand at the start of the process. Adding this glass helps speed up the melting process. The impurities will be removed once again in the second chamber. The pure liquid glass that reaches the third chamber is divided up, ready to be turned into test tubes and coffee pots. Engineers take regular samples to check the machine is taking the right amount each time. For heat-resistant glass, the raw material must be as pure as possible. The chlorine gas removed many of the impurities, but the factory is also full of dust and dirt. These men are putting on protective clothing so that they can do some housework, or in this case, factory work. Keeping it free of dust ensures high-quality glass, ready to produce coffee jugs, for example. Machines are now used to do the work as the glass is far too hot for human hands to shape. To produce scientific flasks or cafetières, the process is quite similar. Molten glass is placed into molds and blasted with a jet of air from above. This stretches the glass while flames burn it from below. This will ensure the glass acquires the necessary strength. The lengthening bulbs of molten glass are encased in a new mold which gives the jug its final shape. When they've cooled down, inspectors can check samples from each batch, but they still have rough edges which need to be dealt with. They're fitted into the next machine, which passes them over more flames. The heat melts away any irregularities to form smooth edges. Now, if you're going to pour coffee from this jug, it needs a lip. The rim is heated to around 900 degrees Celsius and the indentation pressed into place. But if you're having coffee, then you'll also need a slice of cake. To make a cake dish, the molten material is pressed, not blown. Working continually, this machine can produce 60,000 cake dishes every day. However, exposure to all that extreme heat means the machinery needs regular maintenance. But the production line can't be closed down for cleaning. The dirty molds have to be removed whilst the press continues operating. Continual heating tarnishes the molds. The dirt from each previous dish is then transferred to the next dish produced in that mold, and so on. Each mold has to be polished to remove this dirty layer every 16 hours. It's then up to this engineer to return the mold to the machine without getting his fingers trapped. It can then get back to work, making fresh, flame-proof dishes for convenient cooking. When the dishes emerge, they look like the finished article, but like the coffee jugs, they need finishing touches. The dishes are spun under a flame to seal any tiny holes or flatten any flaws that may spoil a smooth finish. Being transparent, one of the benefits of heat-resistant glass is that the cook can see when the dish is done. It's this great glass-making technology that's providing domestic and professional kitchens with cool cookware that won't crack when the heat is on.